Alarm clocks are an essential part of nearly everyone's life. It's seen as a necessity to many because it is, and for good reason. Sleep researchers have found that 85% of people use an alarm clock to go to work. A majority of these people wake up in a dark room. However, waking up to light helps the brain to realize that it's daytime, which in turn means it's time to wake up. Waking up to darkness makes the brain think that it's still nighttime, making it a bit harder to be fully awake, resulting in everyone's mornings being a bit rougher. The goal of this project is to create an alarm clock made using an Arduino that will wake up the user up with a light, giving them a more pleasant and energized start to the morning. For the construction of the first prototype, the focused aspect of the design was getting a servo to raise a platform which will be holding an LED. The servo is an essential part of the system. It will raise the platform with the LED, giving the effect of a sunrise. The servo will be held in place using cardboard and tape. The Arduino will be placed at the bottom, and the platform containing the LED will be attached to the servo. The servo circuit being used in this design is from the Viros Ultimate Starter Kit. Both of the Arduino circuits required the use of code. For the servo, a code titled sweep was used. It made the servo move 180 degrees. The original code was altered by changing the light time for the speed of the servo as to make the rising light slower to simulate a sort of sunset. The code used for the light was a code titled blink. This allows for the light to blink in a set amount of time. The code was altered by removing the blinking function altogether as to keep the LED on the whole time. For the first prototype, the design was rather sloppy. From testing the servo mechanism over and over, there are many glaring problems. One problem is the size of the platform. It's too big and bulky and ends up having a lot of weight. It ends up going onto the ground each time it's at the starting position. Another problem is the placement of the servo. The light should be rising in the middle, and that makes it difficult to do if the servo is placed all the way on the right end of the box. For the construction of the redesigned prototype, the materials that were used consisted of cardboard, duct tape, 10 male wires, 2 female wires, one 330 resistor, an Arduino Uno board with breadboard, and a servo. The Arduino contains the same two circuits from the first prototype, the light and servo circuits. The code also remains the same, the differences being that the platform from the first prototype has been greatly reduced in size, which allows it to be more sturdier. The servo position has also been altered, as to give more space and allow for a better result. A problem, however, that presented itself in this stage was the buffering of the servo. It would be likely each test for the servo to stop moving for a second, then continue on with its objective. The chance of buffering, however, was greatly reduced by changing out the servo arm. The series of tests that are shown are testing how well the servo functions and if it can repeat without fail. If the servo can successfully make it 180 degrees smoothly, then it functions as intended. Tests 1 and 2 both functioned well. However, during test 3, the servo stopped for around 5 to 6 seconds, then turned back and came to its starting point. All of test 4 to 7 worked smoothly, with very few resulting in minor instances of the servo being stuck for less than a second, then continuing on with the task. Compared to the first prototype, this one works significantly better. The overall results from the testing periods prove that the servo mechanism functions well and is effective. Even if there are a few minor instances in which the servo stops, however, in terms of setting out to accomplish my goal, I was unsuccessful in doing so. Even though the project could work and function well, a major problem was that I was unsuccessful in combining code, which meant I could only run one program at once. So even if the servo could go off at a set time, the LED would not. If I was to redo this project to make it function as intended, I would definitely try to get a better understanding of how to read and use Arduino code. This project was to function as intended. Possible tests that should be conducted are how well the light works on waking people up compared to traditional alarm clocks, and what level of brightness works best on waking people up. While the Arduino alarm clock that I've set out to create is not finished, a massive part of it is. What I've created works, a servo mechanism which will move a platform to display light. I, however, am still missing a massive part of the project, the coding. So in short, I was unable to fully produce the project that I had set out to create. If I was more knowledgeable on how Arduinos work, then this project could have definitely been done. I hope to gain a better knowledge of Arduino coding so that I can reapproach this project and get it finished in the future. I'd like to give a big thanks to JFCTC for supplying an Arduino kit, which was the main component being used. Thank you.